This is the circuit that I designed for my final project. It consists of two sensors, one a photoresistor and two a thermistor. My goal for this circuit was to be able to power this small DC motor when two conditions were met, and that was when it was light out and when the temperature was hot. My first op-amp uses two voltage dividers, one for the positive terminal and one for the negative terminal. The positive terminal has a voltage divider that divides 15 volts down into 7.5 volts with two 10K ohm resistors. The second voltage divider on the negative terminal has a photoresistor that's dividing the voltage depending on what the resistance level is. When the resistance level is low enough or it's light enough in the room, then VP is going to have a positive voltage and my output will be a positive voltage. My second op-amp has two voltage dividers, one for the negative terminal and one for the positive terminal, just like in the first op-amp. The positive terminal contains the thermistor in it, so when this thermistor is at a hot enough temperature, the voltage will rail to a positive voltage out of the second op-amp. Once my photoresistor is receiving enough light and my thermistor is at a hot enough temperature, I want to power this DC motor. The way that I do this is that if both of those conditions are met, I need to feed those inputs into two NAND gates to build an AND gate. Now apparently this digital chip can only take in a maximum of 5 volts, as well as a maximum of 7 volt VCC. So what I'm doing right here is dividing my voltage that I'm getting from the output of my first two op-amps down into about 4.5 volts just to be safe. Over here, I'm dividing the 15 volt source into just under 7 volts for VCC, just to be safe once again. Now when both of these conditions are true, I'm feeding two positive voltages into the first NAND gate. Then I'm feeding that output, which will be a 0, into the other NAND gate, which will switch it back into a positive output. And then that voltage comes all the way back up here, and I go back into this chip, and I use this portion as a buffer. The buffer is used to kind of boost the current that I'm not able to get outside of this chip to power my DC motor. Now let's see the circuit in action. In doing so, I need to lower this resistance, and I will do that by holding this, and once this resistance drops low enough, my motor should start up, and sometimes it needs a little bit of help. There we go. As you can see, the motor is running. Might be hard to see, but you can hear it.